Okay, so now that we've talked about the different, how to make radians, convert between degrees and radians, and we've talked about reference angles, coterminal, all those wonderful words, let's pull some of that together in our endeavors to talk about trig functions. Okay, so determine which trig ratios are positive in each quadrant. So we know that each trig ratio is based on an x, a y value, or an r value. Okay, so it's x and y together, or x with r, y with r. Okay, so we know in the first quadrant, all of our x's are positive, all of our y's are positive, and we know that r is always positive. So since that's true, then any of our ratios would have to be positive. So in the first quadrant, okay, all are positive. So when we go into the second quadrant, x's are negative, y's are positive. So that means with an x being negative, y being positive, and r being positive, any of our functions that have an x in them, be it with x and y or x and r, are going to be negative values, because a negative and a positive division will be a negative answer. So only our y's, our y ratios, will be positive. So that's sine theta, right, which is y over r, and its reciprocal, cosecant theta, which is r over y. Okay, so we come into the third quadrant, and x's are negative, y's are negative, so but r is still positive because it will always be positive. So here, x and r will be negative, x and r and x will be negative, y and r and y, those will all be negatives. So the only thing that has the chance to be positive is our x over y or y over x, because a negative divided by a negative is positive. So if you'll recall, x and y are your tangent theta and your cotangent theta. All right, last quadrant, x's are positive, y's are negative. So we have x's being positive, y's being negative, and r's being positive. Okay, so our positives will be x and r together, r with x, but then everything else, x and y, y and r, those will all have a negative value in them. So only cosine theta and secant theta will be positive. Okay, so then how can we determine if the value of each ratio is positive or negative? So we figure out which quadrant 240 degrees is in. So let's see, 180, a little bit more, 240. So it's in the third quadrant. I'll just call that Q3. Okay, so it's in the third quadrant, which means sine will be negative. Okay, 5 pi over 3. Remember, that's pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3 ends up in the fourth quadrant. So that's going to put cosine as positive. And finally, tangent of 150 degrees. So 150 degrees, here's 90, a little bit more is 150, because here's 180. So 150 is in the second quadrant. And in the second quadrant, tangents are negative. All right. So the value of a trig ratio can be found using the reference angle and the sign for the quadrant. Okay, so since the reference angles, right, we can find their value, then we just have to figure out, based on which quadrant it's in, whether that would be a positive or a negative value. Okay, so Let's scroll down just a little here and take a look at some examples. All right, in this first example, it says sketch each of the following angles, find the reference angle, then determine the value of the trig ratio for theta. Okay, so start off by sketching. Okay, and 330, we start here at the x-axis, come around, 270, 330, we're going to end up down in the fourth quadrant. Okay, so 330 is here, 360 is here. That the closest distance to the x-axis is going to be our reference angle, which is 30 degrees. Okay, so we're going to look for the sine of 30 degrees. Okay, we looked at this in lesson 1.5 and we saw that the sine of 30 degrees would be 1/2. But 330 is in the fourth quadrant, and we know in the fourth quadrant sine has to be negative. So this would be negative 1/2. Okay, cosine of 5 pi over 4. So we do a quick sketch. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So 5 pi over 4 is down here in the third quadrant. And we know in the third quadrant, cosine is going to be negative. So it's going to be negative cosine. And what's our reference angle? Well, if this is 5 pi over 4, come all the way around, okay? Our reference angle is going to be right here, the distance between 5 pi over 4 and pi, which, as it turns out, is pi over 4. So our reference angle is pi over 4. Okay, so it's going to be the negative value of cosine of pi over 4. Well, pi over 4 was square root of 2 over 2, so this will be negative square root of 2 over 2. Okay, let's take a look at some more examples. The special angles can be grouped by their reference angles. All right, here at 30 degrees. So this angle is 30 degrees. Okay. We know this is 180, so if we go back 30 degrees, we'd be at 150 degrees. And we go forward, we're at 210 degrees. And then back from 360 gives us 330 degrees. Okay. As radian measurements, 30 degrees was pi over 6. So if we kind of count, there's 1 pi over 6, 2 pi over 6 was 60 degrees, 3 pi, 4 pi, this is going to be 5 pi over 6. Okay. 6 pi over 6, so 210 is 7 pi over 6. And then there's a not shown 8 pi, 9 pi, 10 pi, and finally 11 pi over 6. Okay, so we want to fill those into our table. We have 150 degrees, 210 degrees, and 330 degrees, and pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, for 45 degrees, here was 45, then 90, okay, then it was 135, 180, and here we had 180 plus 45 more, okay, which was 225, and then 270, and then 45 more would be 315 degrees. Okay, so the radians were pi over 4, because we divided pi into 4 equal sections. So here's 2 pi over 4, 3 pi over 4, 4 pi over 4, which makes 225, 5 pi over 4. 270 represents 6 pi over 4, and then 315 degrees would be 7 pi over 4. Okay, so let's put that into our chart. So 45 degrees was pi over 4. Then the other 45 degree angles, or the angles with 45 as their reference angles, was 135, 225, 315. And that was 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. All right, let's scroll down a little bit and we're going to talk about the 60 degree. Okay, with 60 degrees, here this first is 60 degrees, and then we come 60 degrees more, that's 120 degrees. So 180, 240 degrees, 300 degrees, and then finally back to 360. Okay, and then because we divided the pi into 3 equal sections, we know that 60 degrees is pi over 3. 120 degrees is 2 pi over 3. 180, or pi, would represent 3 pi over 3, so 240 is 4 pi over 3. And 300 would be 5 pi over 3. So again, 60 is pi over 3, 120, 2 pi over 3, 240 is 4 pi over 3, and finally 300 degrees is 5 pi over 3. Okay. So learning that chart is going to really help us out. Okay. Express each of the following in terms of a reference angle, then find the exact value of each trig ratio. Okay, so sine 225 degrees, if you don't remember, just flip back. 225 degrees was in the third quadrant. Okay. So since it's in the third quadrant, we know that sine will be negative. So we can, and its reference angle was 45 degrees. So we know that sine of 225 degrees would be the opposite of the sine of 45 degrees, or the negative of. Okay, sine of 45 degrees, the square root of 2 over 2. And since it's in the third quadrant, it's going to be negative square root of 2 over 2. Okay, so sine of 120 degrees. Okay, looking back, 120 degrees is, reference angle is 60. So this would be the sine of 60 degrees. But 120 is in which quadrant? The second quadrant. And in the second quadrant, sine is positive. So it's just going to be positive. So sine of 60 degrees is square root of 3 over 2. So that's my answer. Okay, cosine of 5 pi over 3. Let's see, 5 pi over 3. Where did it go? Ah, that's right, it was part of our 60 degrees, right? 5 pi over 3 is reference angle of 60, and it's in the fourth quadrant. Okay, so it's in the fourth quadrant. 5 pi over 3 was with 60. Okay, so cosine of 60 degrees, and cosine in the fourth quadrant is positive. So we know that that's just going to be 1/2.